Section 3.4, the chain rule. We've taken a lot of derivatives over the course of the last few sections. However, if you look back, they all have been functions similar to the following kinds of functions. R of z is equal to the square root of z, f of t is equal to t to the 50, y is equal to tangent of x, h of w is equal to e to the w, g of x is equal to natural log of x. Now, these are all fairly simple functions in that wherever the variable appears, it is by itself. Now, what about functions like the following? So here we have functions that we can take a look at here. Now, none of our rules will work on these functions, and yet some of these functions are closer to the derivatives that we're liable to run into than the functions in the first set. So we're introducing what we call as the chain rule. The chain rule is going to allow us to be able to find the derivative of these functions. So the chain rule states that if g is differentiable at x and f is differentiable at g of x, then the composite function, capital F, which is equal to f composite g, defined by f of x, which is equal to f of g of x, is differentiable at x, and f prime is given by the product. So f prime of x is going to equal f prime of g of x times g prime of x. Now, in Leibniz notation, if y is equal to f of u and u is equal to g of x are both differentiable functions, then we'd say that dy over dx is equal to dy over du times du over dx. Now, what we're going to do is, just to apply this example, we want to be able to use the chain rule to differentiate the following function. So let's go ahead and do that. So the function is r of z, which is equal to the square root of 5z minus 8. Okay, so what we want to do is we want to first define what our functions are. Well, the first step is that we're going to say that our function f of z is going to equal the square root of z. Okay, and then we're going to say that g of z is going to represent what's underneath the radical, which is 5z minus 8. Okay, so now we want to find, okay, what is the derivative of f of z? Well, we know that whenever we found the derivative of the square root of z, we end up getting 1 over 2 times the square root of z. And then if we want to find the derivative of g of z, well, the derivative of 5z is 5, and the derivative of minus 8 is 0. So now we have our functions, and then we have our derivative of our functions. Okay, so now we're going to use the chain rule. So the chain rule tells us that in order for us to find the derivative of r prime or r prime of z, well, that's going to equal f prime of the function g of z and then multiply that by g prime of z. Okay, so what it says here is, okay, we want to find f prime. Well, what is g of z? Well, we know that g of z is 5z minus 8. And then we're going to multiply it by g prime of z. Well, we know that g prime of z is equal to 5, so this is times 5. So if we want to find the derivative with the input of 5z minus 8, well, let's go ahead and talk about that. So that means we want to find the derivative of the square root of 5 5z minus 8. Okay, and now keep in mind that this becomes 5z minus 8 to the 1/2 power. And then when we find a derivative of that, it's going to be 1/2 times 5z minus 8 to the 1/2 minus 1, which is 2/2. So we end up getting 1/2 times 5z minus 8 to the negative 1/2. So over here, we're going to end up with 1/2 times 5z minus 8 to the negative 1/2 times 5. So now if we want to rewrite this without the negative exponent, then what we end up getting is 1/2, and then we can write this as the square root of 5z minus 8 times 5. And so therefore, we're going to say that the derivative of this function is going to equal 5 divided by 2 times the square root of 5z minus 8. Okay, so here we got the derivative using the chain rule. Okay, now let's discuss this a little further. Okay, so in general, we don't really do all the composition stuff in using the chain rule. That can get a little complicated and in fact obscures the fact that there is a quick and easy way of remembering the chain rule that doesn't require us to think in terms of function composition. So let's take the function from this previous example and rewrite it slightly. R of z is equal to 5z minus 8. This is the inside function, and raising it to the power of 1/2, which is the outside function. Now, this function has an inside function and an outside function. The outside function is the square root or the exponent of 1/2, depending on how you want to think of it, and the inside function is the stuff that we're taking the square root of or raising to the 1/2, again, depending on how you want to look at it. And then the derivative is then, well, the r prime of z is equal to 1/2 times 5z minus 8 to the power of negative 1/2 times 5. Well, this is the derivative of the outside function, and what's inside here is the inside function left alone. And over here, this is the derivative of the inside function. So in general, this is how we think of the chain rule. We identify the inside function and the outside function. We then differentiate the outside function, leaving the inside alone, and multiply all of this by the derivative of the inside function. In its general form, this is f prime of x is equal to the derivative of the outside function, the inside function left alone, times the derivative of the inside function. So we can always identify the outside function in the examples by asking ourselves, how would we evaluate the function? So for instance, in the r of z case, if we were to ask ourselves what r of 2 is, we would first evaluate the stuff under the radical and then finally take the square root of this result. The square root is the last operation that we perform in the evaluation, and this is also the outside function. The outside function will always be the last operation you would perform if you are going to evaluate the function.